have you ever stopped to wonder how your computer can find one specific photo or one email in a sea of thousands, almost instantly? It seriously feels like magic, right? But it's not magic. It's actually a really fascinating story of solving one problem at a time. So let's pull back the curtain and see how it really works.
Okay, first, let's start with a total nightmare scenario. Just imagine you spend hours typing up your budget, tracking your gym progress, making the perfect playlist, and then the second you close the app, poof, it's all gone. Every single time. That app would be completely useless, wouldn't it? Well, this is the very first problem that every single computer program has to solve.
So how do we fix it? The solution is a simple but really powerful idea called persistent files. All it means is that your data needs a permanent home, a place where it can live on, even when the program is closed or the computer is turned off. Honestly, this one concept is the foundation for everything else we're about to talk about.
So let's dive into that. How do we actually solve this whole vanishing data problem and give our information that permanent home it so desperately needs?
Well, the most basic way to do it is with something called a flat file database. Now, don't let the technical names scare you off, because I guarantee you've seen these a million times. If you've ever opened a CSV file in Excel or Google Sheets, that's it. It's just a simple text file where all your data is organized in rows, with commas separating all the different pieces of information.
And the process for actually saving data this way is just as straightforward as you'd think. The computer opens the file, it grabs the new info, say a name and a phone number, it formats it with the commas, writes that new line to the bottom of the file, and then closes it. Simple. Problem solved. Our data doesn't vanish anymore.
But you know how it is. We solve one problem, and we immediately create a new one. Okay, so our data is safe now. That's great. But it's just one long, unorganized list. How in the world are we supposed to find anything in there without it taking forever?
This analogy really just hits the nail on the head. Searching through our data file right now is like trying to use a dictionary where all the words are completely jumbled up. If you wanted to find the word zoo, you'd literally have to start at page 1 with the A's and just read every single entry until you finally hit it. In the tech world, this has a name. It's called serial data. The data is just stored in the order it came in, with no logic to it. And that brute force method of checking every single item one by one from the very beginning, that's called a linear search. And sure, it works, but with a big file, it is painfully slow. So clearly, we have a mess on our hands. The next logical step has to be bringing some order to all of this chaos. We need a better system. And the first step is so beautifully simple, you're going to love it. We just sort the data. That's it. Put everything into a logical order, just like a real dictionary. And by doing that one simple thing, we transform our messy serial data into clean, beautiful, sequential data. So now all our names are alphabetized, or maybe our transactions are all sorted by date. It's the exact same information, just organized. And that makes it so much easier to find what we're looking for. Now, sorting is a huge leap forward, a massive improvement. But when you're dealing with the gigantic data sets that power our modern world, computers need an even smarter trick up their sleeve. They need a superpower. And that superpower is called indexing. Honestly, the best way to think about it is like the index at the back of a textbook. The book itself is sorted by page number, right? But the index is a separate, alphabetized list of topics that tells you exactly which page to jump to. It's a map, a shortcut to your data. See, once you have an index, you unlock this unbelievably clever and fast way of searching called a binary search. Instead of looking one by one, a binary search works by chopping the problem in half, over and over and over again, getting you dramatically closer with every single jump. So let's put them head to head. You've got the linear search just plodding along, reading the whole book from cover to cover. Then you have the binary search, which is like an expert librarian who knows exactly where to flip, instantly throwing away huge chunks of the book they know they don't need. The difference in speed isn't just a little bit better, it's astronomically better. Okay, let's watch it in action. Let's say we want to find the letter R in the alphabet. The old linear search would start at A, then B, C, you get it. But a binary search, its first jump is right to the middle, M. Now, the program knows R comes after M, so boom, it throws out the entire first half of the alphabet. It's gone. Its next jump is to the middle of what's left over, which is T. Okay, now it sees that R comes before T. So what does it do? It throws away that whole second section. It's just zeroing in, jumping to the middle of the tiny little slice that's left, P. Just a couple more of these quick little hops, dividing the tiny space that's left each time, and
bam, it lands right on R. It's just so much faster. So, how many steps did that whole process take? Just 5. 5 little jumps.
And what about our old, slow, linear search? That would have taken 18 steps. 18! This little example shows it all. It's more than 3 times faster here. Now just imagine the difference when you're searching through millions or billions of items. It's staggering.
This is all cool in theory, right? But where do we actually see this stuff in action? The answer is absolutely everywhere. You're using this all day long and you probably don't even realize it. Take it from Diana Goria, a software engineer at Google. She confirms that when you type something into that search bar, Google isn't reading every single web page on the internet. No way. It's using these massive pre-built indexes to jump directly to the relevant results. That's the secret to getting answers in milliseconds. Or how about this one from Twitter? A software engineer there, James Harlow, explains that to find the mutual followers between 2 huge accounts, a simple search would need to make hundreds of billions of comparisons. But by using a binary search, that number plummets down to the millions. It literally makes the impossible possible. And this chart just says it all, doesn't it? Look at that difference. We're not talking about a small improvement here. It's a complete game changer. It's the difference between a feature that works beautifully and a feature that would just crash the entire system.
And the list just goes on and on. Fintech companies use this to find one of your transactions instantly. E-commerce warehouses use it to find a single package in a warehouse filled with millions of them. Even city transit systems use it to analyze massive log files to keep the trains running on time. This isn't just theory, it's the invisible engine that makes our modern world run.
So, as we wrap up, think about the journey we just took. We went from data that just vanished, to a messy, disorganized list, to a neatly sorted file, and finally to a superpowered indexed system. Each step solved a critical problem and unlocked a whole new level of possibility. And that leads to one final thought. What about the data in your own life? Your fitness logs, your budget spreadsheets, your gaming stats. How could a little bit of sorting and organization make all that information faster and more powerful for you?